Hello everyone, welcome first year students, English section, Faculty of Commerce, Red City University. It's me, Reem Sobhi. I am a teaching assistant at Insurance, Statistics and Mathematics Department. I will be with you in the sections of Pure Mathematics course. This is part 2 from our first section on chapter 1 titled Relations and Functions. Example 15, determine if the following graph is a function or not. In this example, we see here the fourth form of the relation. We just defined three forms of the relation, which are correspondence and ordered pairs and also equations. And this is the fourth form of the relations which is graph. In this example, we need to determine if this graph is a function or not. So to determine whether this relation is a function or not, we use the vertical line test. The graph defines y as a function of x if any vertical lines that can be drawn on the graph intersects the graph at only one point. But if the line intersects the graph in more than one point, so this wouldn't be a function. So here we would like to test this graph by the vertical line test. So we would draw a vertical line like this to intersect the graph. And in this test, the line or the vertical line intersects the graph in only one point. So this is a function. But if the line intersects the graph in more than one point, this wouldn't be a function. So this relation is a function. And the correct answer is D. This is a relation and a function. Example 16, determine if the following graph is a function or not. Again, we will use the vertical line test, which intersects the graph like this. And in these tests, we found that the vertical line intersects the graph in 3 points, as you see here. So this is not a function, because if the vertical line intersects the graph in only one point, this would be a function. But if it intersects the graph in more than one point, this wouldn't be a function. So this graph is a relation but not function, and the correct answer is C. Example 17, also determine if this graph is a function or not. Again, we will use the vertical line test like this, and we can see here that the vertical line intersects the graph in only one point, so this is a function. So this relation is a function, and the correct answer is D. Example 18, determine if this graph is a function or not. Again, by using the vertical line test, we find that the line intersects the graph in only one point, so this is a function, and the correct answer is D. Example 19, determine this graph is a function or not. Again, we will use the vertical line test, and we can find here that the line intersects the graph in 2 points, here and here. So this is a relation but not function, and the correct answer is C. Example 20, also determine if this graph is a function or not. Also used by using the vertical line test, we can see here that the line intersects the graph in 2 points. So this is a relation but not function. So the correct answer is C. Example 21, from this graph, determine the domain of the following function. In this question, he's giving you a graph and he needs you to extract the domain from this graph. by taking the point here on the graph, we have the first point, minus 6 and minus 6, and our domain would be the values of each values of the x in the points. So the domain equals from this graph only the first values of the points, which are minus 6, minus 4, minus 1, 3, and 7. This is the domain of the graph, and the range of the graph would be the second values of the ordered pairs, which are minus 6, 0, 4, minus 5, and minus 3. In this question, he's asking you about the domain only, so the correct answer is B. Question 22, the range of the following function is. In this question, he needs you to extract the range from this graph. And the range is the second component of the ordered pairs in this graph. And by taking the points on the graph, the second component would be the range of this function. So the range equals 7 and 5, 3, 2, and 5. And the correct answer would be B. Question 23, the domain of the following function is. Also in this example, he needs you to extract the domain from this graph of the function. And the domain is the first component of the ordered pair. So this is the domain, and so the domain values equals minus 3, 0, 3, and 5. And the correct answer is C. Question 24. The range of the following function is. From this graph also he needs you to extract the range here. And the range, as we know, is the second component of the ordered pair. So this is the range of the function. And we can write the range as range equals minus 3, minus 1, 1, 3, and 5. And the correct answer would be B. The next question here is determine if the following statement is true or false. Statement 1, if there is more than one element in domain corresponds to one element in the range, then the relation is a function. This is, of course, is false because we said that each element in the domain should respond to exactly one element in the range. But here he's telling you that more than one element in the domain corresponds to one element in the range. So this is false. This is not a function. This is a relation. Question 2, or statement 2, if there is more than one element in domain corresponds to one element in the range, then the relation isn't a function. This is true, as we just said before in the statement 1. Statement 3, if any element in domain corresponds to more than one element in the range, then the relation is a function. If any element in domain corresponds to more than one element in range, then the relation is function. This is false, because each element in domain should correspond to exactly one element, not more than. Statement 4, if any element in domain corresponds to more than one element in range, then the relation isn't a function. Also, this is true. Statement 5, the relation are 2 and minus 2, 0 and 0, minus 2 and 2 is a function. This is true because each element in a domain corresponds to only one element in the range. So this is a function. Statement 5, the relation isn't a function. Here, each element in domain corresponds to only one element, or exactly one element in the range. So this is a function and this is false, not true, because here he is saying it's not a function. Statement 7, all relations are functions. No, this is false. Not all relations are functions. Statement 8, all functions are relations. Yes, all functions are relations, as functions is a special case of relations. So all functions are relations, but not all relations are functions. So this statement is true. Statement 1, the relation can be ordered pairs, correspondence, graph, or an equation. This is true, because these are the types or forms that the relation can be defined in. Statement 2, the function can be ordered pairs, correspondence, graph, or equation. This is also true, as functions are a special case of relation, so it can take any form of the relation. So this is also true. Statement 3, not all functions are relations. This is false. All functions are relations, because functions are a special cases of relations. So all functions should be a relation or is a relation. So this is false. Sorry. Not all relations are functions. This is of course true. Not all relations are functions. If there are elements in range, doesn't correspond to elements in the domain, then the relation isn't a function. Again, if there are elements in range doesn't correspond to elements in domain, then the relation isn't a function. To be a function, the relation to be a function, each element in domain should correspond to exactly one element in the range, but not all elements in the range should correspond to an element in the domain. So this statement is false. Statement 6, if there are elements in range, doesn't correspond to elements in the domain, so then the relation is a function. Here also is false, as the function, in order to determine the relation is a function or not, is depend on elements of domain, not the elements of the range. If you have some elements in domain doesn't correspond to elements in the range, so this is not relation, and as a result this is not a function. But if you have elements in the range doesn't correspond to any elements in the domain, so this doesn't mean it's not a relation or it's not a function. Okay. Statement 7, relation, this relation is a function or not. by going to the first elements in the relation, or the values of the domain, we can see here that 0 corresponds to -2 and 2, and this is not a function. This is a relation but not function. So the answer is false. Is this relation, statement 8, isn't a function? Here, yes, this is not a function because 0 here corresponds to -2 and 2, so this is not a function, so this is true. This relation is a function, statement 9, by checking the first component of each pair. We find that there is no repeated elements in the first components, so each element in the domain corresponds only to exactly one element in the range, so this is a function and the statement is true. Statement 10, if this relation isn't a function, also by checking the first component, we can see that there is no repeated elements, so this is a function, so the statement is false. It's a function, not a function. This relation is function or not, also by checking the first components. We see here in this relation that the first component of the pairs, which is 4 and 8, is repeated, so the 4 corresponds to -4 and 4, and 8 corresponds to -8 and 8, so this is not a function. This is a relation but not function, so the statement is false. Thank you for watching this video and sharing your time with us. Hope it's useful for you. See you at the next part from this section. Goodbye and good luck to you all.